In this video, we look at the probability of any Gaussian random variables. We want to review that Qx. Qx is the probability of big X, that's a random variable, greater than the value of small x. And this big X, this random variable, is standard normal with zero mean and the variance is 1. Now, what about if I have a random variable with any mean and any variance? So what's the probability of this random variable x greater than a value small x? And this, we can do some derivations that equals q smaller x minus m divided by sigma. Sigma, that's the standard deviation. Let's use an example. What about if I have a random variable with mean of 2 and sigma squared equals to none? So from here we have sigma equals to 3. And let's find out the probability of x greater than 2. What is equals to? We can see here if this is 2 and the mean is at 2. So probability greater than 2, probability of x greater than 2 should be half, and that should be equals to q0. So let's see. That should be equals to, according to this relationship, that's x small x equals to 2, that's m equals to 2, and sigma equals to 3. That is equals to q0. So that equals to half. So we can see here, in this case, this is a Gaussian random variable with non-zero mean with any variance not equals to 1. What's the probability of this random variable greater than a value of x? That equals qx minus m divided by sigma. So that's this. Let's look at another example here. What about this probability of x less than 3? Let's see here. And we know that probability less x less than 3, that equals minus probability of x greater than 3. Because Q function is defined as x greater than a value, so any probability, if we want to use Q function, we want to express the probability into the format of probability of this random variable greater than something. So that equals 1 minus probability of 3 minus 2 divided by 3. That equals 1 minus p 1/3. And then using the table, we can obtain the probability of this random variable x less than 3. And remember, this random variable has this distribution. And don't confuse the notation wise here. And here they use big X as well. I'm using the same notation as our text. They specify this X has this distribution here. And this X, they use the same notation, X, another random variable, X, but they have different distribution. So you always want to check what is the distribution of this random variable. Now let's look at another example here. I have random variable x has a Gaussian mean of 1 and sigma squared equals to 4. Here, what's the probability of x in between 5 and 7? 1, right? The mean is 1. We want to have 5 and 7. So really the probability, that's this area. But we want to use Q function. So Q function, we want to express this probability using two probabilities and take the difference. And this probability, this area, you can see that's the difference of probability x greater than 5. That will be this area greater than 5. And then minus probability of x greater than 7, that will be this area. So if we take the difference of yellow and purple, we're going to get blue. And then we use this formula, this relationship here. And we can see this probability is equals Q2 minus Q3, that equals 0.002.